Alright, what I'm really trying to do today is prove. So, there's this theorem in mathematics, specifically real analysis, called Bolzano-Weierstrass theorem. Okay, sounds a bit so weird, like, maybe it's not weird for Germans or Austrians or any of you guys there. So, let's start off with some basic ideas or concepts that you need before you jump into this theorem and prove that. Okay. So what we want to know is what is a sequence. So you can think of a sequence of real numbers. Okay, everyone knows what a real number is, I'm assuming. So a sequence of real numbers is an infinite list per se. So I've written down here like an, and it's just some term, some subscript we use by convention for sequences. So it's just basically a list of real numbers. So we have any real number can be in that, anything can be there, can be given by a formula. Say an is equal to, let's say, 2 of n, which means that where n is a real number, so 2 times n is a natural number, also fine. 2 times is 2 times 1, 2 times 0, 2 times blah blah blah, all the way to whatever, infinity. So that's a sequence. It's just a list of real numbers. It can be 1, pi, 2, 3, 4, 6.1, root 3. Pick your favorite real number and just throw it in that list. That's a sequence. Okay. So we need one more concept before we go there, which is a subsequence. So a subsequence is, given a sequence, say I have this 1, pi, 2, 3, 4, 6.13. We have another sequence such that the elements, it's also an infinite. Remember, a subsequence is also a sequence. So subsequence is a list of real numbers, infinite list of real numbers, such that how we pick elements to put in that subsequence is dependent on the original sequence. So if I have a sequence, say 1, pi, 2, 3, 4, 6.1, root 3, we pick a subsequence by picking certain numbers from there. Can be all the thing, then it means the subsequence is equal to the sequence. But in this case, say we pick certain numbers, say 1 or pi, or we skip 2 and 3, we pick 4, 6.1, we skip root 3, and we pick whatever else is on the sequence. So as you can see, it's a subsequence is like, it's like a small thing, not a small thing per se, it's something which is contained inside the sequence. So every element of a subsequence is inside the original sequence. So one more thing, boundedness. Yeah, so if a sequence is bounded, suppose this blah 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 blah, if it's bounded, I mean, this is not bounded because we don't know what comes next, but suppose it's bounded, it means that for all the numbers in that list, there exists a real number which is bigger than all those numbers. Say, suppose I have a list an 1, 2, or maybe 1, 1 by 2, 1 by 3, 1 by 4, da 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 da. So it's a list given by 1 by n, right? I mean, sequence given by 1 by n. So the natural thing to consider here is, what would be a real number which would be bigger than all these elements in this sequence, right? So we have 1, we have half, we have 1 by 3, 1 by 4. The number need not be in the sequence. So let's say 2. 2 is bigger than 1, 2 is bigger than 1 by 2, 2 is bigger than 1 by 3, 2 is bigger than 1 by 4. So it means it just means that there exists a number, or we can pick a real number that is bigger than all the other elements within that given sequence. And that's all we need to know to consider Bolzano-Weierstrass theorem. Weierstrass theorem, yeah. So now we know what we need to know about that, and now we kind of know how to pronounce the theorem. So let's state the theorem. Bolzano-Weierstrass theorem. Bolzano-Weierstrass theorem states that if we have a bounded sequence, say an, right?